Mr. Bill's Physics channel. Welcome to the family, everyone. Just going to tell you a little story as I walk around my classroom today. I was in a coffee shop in the south side of Glasgow just the other day, and I was meeting with one other person, and this person was called A-Road. And A-Road bought a coffee, a nice flat white for $2.90, and sat down beside me, and we had a little bit of a chat just about how the roads were going and how busy it was these days. And then we saw a B-Road coming in, and the B-Road sat in another booth and bought a cappuccino, and it was just sat in another booth because we can't obviously sit together because of social distancing reasons on all of these things. But I could see that he was a little bit exhausted. A lot of people on B-Roads at the moment with going to country lanes for walks and all of that, but he was having a good time. But we saw a motorway coming in, and the motorway was pretty scary. Someone who maybe, I guess, doesn't often come to a coffee shop, and we were just getting a little bit nervous and like, why is this guy here? And we should be more inclusive, but we're just a wee bit nervous about it. But they came in and they went to the other side, and we're like, hopefully he doesn't cause any ruckus in the coffee shop. But after that, this single white line came into the room, and we all just stopped and we all just stared at each other. Even the motorway was like turned around and looked at this single white line, and I bent over and I whispered to the B-Road and I said, "Who's that?" And he says, "That's the cycle path." Hope you like that one, National 5. Right, let's get on to the lesson. National 5, did you like that? That was a bit of fun. I hope you did. I'm just going to go through this slide now. We're going to be talking about series circuit laws today. And I just want to very briefly talk about the fact that we have 177 subscribers, and it's because we have a new following. So I'm just going to show you that new following. It's S2. S2 have found this channel, and they are now watching it and looking forward to that weekly update or upload from these videos. So we just want to say thank you to every S2. You're our future National 5s. We are delighted that you're going into this channel, and we just welcome you to the family. Alright, so the next generation is coming up, so these videos will continue. So thank you, S2. Now, current in series circuit, that's what we're going to talk about today. Now, I've got not a lot of time to go through this, but I've got separate videos that I'm going to jump to that explains the experiment. So the first thing we're going to do is set up an experiment as like this, and I'm going to go and just snap to the video now so you can see me talk through this experiment about current in a series circuit, and then we're going to come back and look at the results and understand why. Okay, so I'm going to snap to you now. Alright, National 5, this is the current in series circuit setup. So we have the supply voltage set to around about 4 or 5 volts. We have an ammeter that I've not plugged in yet, and we have this series circuit board. So you can see that there's a supply voltage here, and then we have it connected in series all the way round. Now, to do this experiment, we need to fit an ammeter into these bits here. So this is A, B, C and D, and we're going to find out what the ammeter reading is at each of these points and what happens to the reading. So let's just do this quickly. So if I take that out and I put this in here and this in here, we get a reading of 0.1. Now don't worry about the negative, that's just the way I've wired it up. 0.1. Okay, so we'll take that out, we'll record that later, 0.1. We'll put that back in, and then we'll try the next one. So take this out and fit the next one in. So let's see. So again, I'm just doing this by hand, so let's have a look now. 0.11. Okay, so again, quite similar. 0.11, the last one is 0.1. Alright, then I'm going to take this out. I'm going to reconnect this so it's all one series circuit again. And sorry for the movement of it all. Alright, then I'm going to put in my ammeter back into here, and this time I'm reading 0.0, back up to 0.1. okay, 0.1. okay, so that's 0.1, 0.11, 0.1. So let's try the last one. Let's take this out once again, put that, I guess we could just put that over here, and let's put this in one more time to here, and let's see what the reading is. Okay, 0.11. So National 5, what we just found out there, very quickly, I've just done it very quickly. I put the ammeter in each of the A, B, C, and D's, and we see that this is 0.1, 0.11, 0.1, and 0.11 amps. So in a series circuit, every part of the series circuit will have the same amp reading. Okay, so no matter where you are in the series circuit, the ammeter reading should always be the same. And in this case, everything was roughly about 0. Well, that should have gone to 0.09, but 0.1 roughly. Okay, so everywhere in the current in a series circuit should be the same, and that is the law for current in series. Welcome back, everyone. We have got the results in. We've got 0.1, 0.11, 0.1, 0.11 amps. They should all be the same. Okay, and I said that in the video. So in a series circuit, the current is the same at all points. Regardless of where you are, the current is the same. Okay? So that is the first thing. Now the second one, voltage in series circuit. We're going to set a new experiment, very similar to the last one. And again, I'm going to just snap over to that video and you can watch me talk through the circuit there. Okay, I'm going to start to you now. Alright, National 5, we're back in with parallel circuits this time. So again, we've got the supply voltage. We've now got this connected in with voltage or a voltmeter. We've got the same setup as before. Now, last time we took wires out to try and find the ammeter reading because ammeter only is connected in series. However, a voltmeter is connected in parallel. So all we need to do for this one is connect it across the points. So we're going to do A, B, C, and D. So this time it's going to be slightly different positioning because we want to find the voltmeter reading across the components. So the first one, okay, let's do this one here. So let's see what this reads. All right. So if I can get this lead in here, there we go. So we're reading at 1.09. So 1.09. Okay, for the first one. Then all I'm going to do is I'm going to move these onto the next one, so the next resistor over here. So I've put it into the other resistor, that's B, 1.6. Okay, 1.62. Okay, so slightly different, not the same this time. Definitely got some sort of difference here. We've got that there, that there. Let's see what we get this time. Wow, okay, big jump, 2.13 or 2.1. Okay, so now let's put this over the last one, which is the voltage supply. Now this is not 4 volts. I've got it at about 5/6 volts. All right, just because this is a wee bit older, so it's going to lose power over time. Okay, so if I do that, that's what we read now. Okay, big jump into 5.12. Right. So if I can remember correctly, that was 1.09, that was 1.62, and that was 2.11. Alright, and we've got 5.14 now. So can you see what's happening? With this setup, as we put the voltmeters across, we should find out that this resistor, the voltage across this resistor, and the voltage across this resistor, and the voltage across this resistor should all add up to this, the supply voltage. So that was about 1, that was about 1.6, that was about 2.1. So if we add them up together, we should get something really close to 5.1. It's not going to be ideal because this is not a perfect circuit, but can you see that this law means that you add up all the components in the circuit to add up to the supply voltage, and that's the law for voltage. Alright? Right, back to the board. Okay, we're back. So let's look at the results that we got for this one. So this one's slightly different. We know that the resistances or the voltages here are different, but we do know that they all add up to the cell voltage, okay, the supply voltage. So what we should have found out, and I said it in the video, is that all of the voltages in the circuit, the components of the circuit, should add up to the supply voltage, okay? So we've got two laws. Current, everything's the same, no matter where you are in the series circuit, and voltage, all the components should add up to equal the supply voltage. And if the resistances are more, then there's going to be more voltage in those components. But it should all add up to the supply voltage. Right, that's it. That's as easy as it is for today. Okay, the bell's gone. It's time to teach S2. If you're that S2 class, I'm excited for you to come into the class. Alright, have a great week, National 5. Well done, everyone, and I'll see you next week.